Cool. Hey everyone. Today I'm going to be going over or continuing off my computer science journey and talk about divide and conquer. This concept is one that took me a while to grasp when I was in college. It's a little bit tricky because it's easiest explained, I think, with recursion, but I found recursion kind of weird when I first saw it in high school. So, yeah, let's just get into it. Enough blabbing. So, yeah, I think the fundamental idea of divide and conquer is not really that difficult. Um, I can hear you guys, squirming in your seats as I say that, but it really is what it means. I mean, you take an array, in this case where, we sort it. Well, the whole goal is to sort it, and we do it through divide and conquer. So at each iteration, we divide the array in half. So we divide it. Two pieces of the array, 38, 27, 43, and 10. Divide again, 38, 27. Divide this side as well, 43, 10. Now, these little pieces are now considered sorted. Like an array of one element is considered sorted. I mean, because there's only one element. So these problems originating from this bigger problem are now are solved problems. Like these are all subproblems, but this is like at the root, at the really base level. And now from here, we can start sort of going back into the higher level in the hierarchy, except it's gonna, in this diagram we do it the other way, and we then compare these little base problems. So 38 with 27, which is greater? Well, 38 is greater, so we're gonna take this side, put it to the left, this side put to the right. 27, 38. This side we have 43 and 10. 10 is less than 43, so 10 goes on the left, 43 goes on the right. Now we have these two problems, which is a little bit more complex. So we conquer, right? In this case, we have a call of 2738, and here we have a call of 1043. So let me explain this more deeply. So we were able to break this down into 38, or here, let's do this to make this easier. 38, 27, 27, 43, and 10. These are the sub problems that we broke this down into. And for each of these, well, we compared 27 with 38, and we merged these arrays into now 2738 and 1043. But now, how do we merge these into 10, 27, 38, 43? This is like the part that tripped me up when I was first looking at this. And it's actually a lot easier than you think. Here, for this transition, it was a lot simpler because these were subarrays of one element. But for here, we can sort of just have a simple pointer start at 27, and we start at 10, which is greater, or which is less. 10 is less, so we're going to put 10 to the array. Move our pointer to the right. Now we're here. 43 or 27 is less than 43. So we're going to take 27 and put it right here. Move our pointer. 38 is less than 43. So we take 38, put it here. This is done now. Done. And now 43 is left. So now we have 10, 27, 38, and 43. And we actually did this before with even with this simpler problem, except the arrays were, well, I mean, it was a lot simpler because you would just have one pointer here, one pointer here. It wouldn't even move. You just see 27 plus 38. Bam. Same with here. 10 is less than 43. Except there's just nowhere to move the pointers because these arrays are size 1. So, yeah. So that's divide and conquer. You take this first half, divide the array into tiny pieces. And then after that, you conquer. Take those problems and go back into the original. I consider that I think the conquer actually means referring to like the base problems, but I like to think of it like this more, like a 2-step process, just to make it easier for me. But yeah, that is divide and conquer. Like I said, I'm not going to go over implementation because I feel like the concepts are much more important to understand. And with AI, you can generate implementations pretty easily. But I can always create videos to explain implementation. But it's a lot easier to implement when you know how the concepts work. So yeah, thanks for watching my video and listening. Like and subscribe. See you guys later.